Hello students, in this video we'll discuss about deterministic pushdown automata. The last video we have discussed about PDA conversions, PDA to CFG and CFG to PDA, but most of the in exam you got the CFG to PDA only, that to one time. So that's why we focus more on CFG to PDS. And of course I gave you simple example how to convert a PDA to CFG also. Then what are the types of PDS? See, we have two types of automatas, right? Finite automata we have two types. One is DFA and another one is NFA. So DFA means on any state, if you read any input symbol, it should go to exactly one state like this. NFA means on any state, if you read any input symbol, it may go to zero state or one state or more state like that. So same state, same input symbol, but we are going to two different states. Means here on Q naught, if I read A, okay, on Q naught, if I read A, I'm going to Q naught only, Q1 only, one state. But here on Q naught, if I read A, I'm going to Q1 and I'm also going to Q naught, two states. So this is non-deterministic in nature, but this is deterministic in nature. Same like deterministic PDA. So PDA is also categorized into two types. Okay, so one is DPDA and another one is NPDA. Deterministic pushdown automata and non-deterministic pushdown automata. Same concept, guys. Here, what does mean by DPDA? So on any state, if you read any input symbol, right? In NFA, what in DFA, what we have written, then it must go to only one state. Like if it is Q naught, then only one state. But DPDA means not only one state, on any state, if you read any input symbol on a particular stack symbol, then it must go to the same state by performing the same operation. Right? This is DPDA. On any state, if you read any input symbol on a particular stack symbol, then it must go to the same state by performing the same operation. If states are different, not DPDA. If operations are different, not DPDA. For example, if I take like this, Q naught X Y, the input symbol is X, top of the stack is Y, and we are going to Q1 by performing the push. And for the same input symbol, same stack symbol, and if you are going to the same state by performing different operation, this is push and this is pop. See, same state, same input symbol, same stack symbol, same next state, but different operations. So this we can call it as NPDA, right? Or in another case, let me go with this. See, same state, same input symbol, same stack symbol. Okay, we are going to the same state but different operation. We are performing the same operation but going to the different states. In this case also it is NPDA. If you have such, then also it is NPDA. Means, what is the definition of this DPDA? Means, on any state, if you read any input symbol and a particular stack symbol, then it must go to the same state by performing the same operation. If states are different, NPDA. If operations are different, NPDA. Right? That is the definition of DPDA. Of course, whatever we are taking here. Right? Now, if it is epsilon, then that must be empty. Right? So we'll discuss that with a simple example. Right? So every regular language can be accepted by the DPDA that have a final states, but the deterministic PDA and the PDA doesn't have the same power, because okay, I'll tell you that. Don't worry, so don't get confused with this. So one is DPDA, right? Every regular language can be accepted by the DPDA, right? If it is regular, that can be accepted. So we can say that regular languages are subset of DPDA. But DPDA is subset of PDA. Means not all languages which are accepted by the PDA cannot be accepted by the DPDA. That is the meaning of the DPDA is subset of PDA. we can say that the number of languages accepted by the DPDA is not equivalent to the number of languages accepted by the PDA. Means there are some CFLs which cannot be accepted by the DPDA. For example, WWR. So this is a language which is not accepted by the DPDA but accepted by the PDA. That we'll discuss, don't worry, in the next slide. Right? So then how we can identify it? Okay, that's what we have discussed, right? So this is the next one to be taken. Yeah. So first WCWR, this we have taken here. See, here I know what is a center point. Like if I take A, B, B, right, A, B, B, C, B, B, A. We have already constructed the machine for it. Let me just go through with the machine here. Okay. So what we have already constructed like this, Q naught, A, Z naught, you push it, A, push it, AB push it, BZ push it, BA push it, BB push it. I know exactly until which symbol I should push. For C, no push, no pop. Why? Because C is a center point. After C, BB pop out, A pop out. This is what we have discussed. So here I know exactly until which symbol I should push and after which symbol I should pop out. Right? So if I take A, B, B, A, B, C, B, A, B, B, A, I know until which symbol. I can tell exactly until which symbol I should push, after which symbol I have to pop. So until C you push it, C no operation, and after C if both are same, pop. If I know exactly when should I push, when should I pop, then we can say that there is a DPDA existed. Yes. So this is DPDA. We can write it. I know exactly. But when you take WWR, no C inside it. Means what? What is the language here? Epsilon, AA, BB, ABBA, or AAAA, or AABBAA, or ABBBBA, so on like that. So in this case, until which symbol I should push and after which symbol I would pop. This is a mid. But how the PDA knows that the mid, because we cannot perform the computations, right? Earlier, I know exactly until which symbol I should push, after which symbol I have to pop. For example, if you take another language like A power n, B power m, C power n, what we have constructed earlier, I know for every A push it, for every B no operation, for every C pop A. I know, I can tell you exactly when should I perform a particular operation. So that is DPDA, deterministic. Exactly I know. But non-deterministic, I know somehow it is possible with the stack. You push until mid, after you can pop out. You push until mid, after you can pop out. Somehow it is possible with the stack, but I don't know exactly what is the center point of that language. So in that case, how I am supposed to do it? How can I write it, right? So what I am doing here, I don't have a particular mechanism to prove what is the center point. Then what is what I am doing here? So simply whenever you have like this, okay, so center point, so before and after center point the stack symbol is same, but it is not always. For example, if I take ABBA, you push A and for this push it, if both are same, pop out. I can say that if the input symbol and top of the stack both are same, center point, but it is not always. Here see, for example, A first, both are same, but this is not the center point. For example, if I take AABB, so for A, push it for A, this is not the center point. Then what we have to do? In this case, see, you have to assume two ways. If the input symbol and top of the stack both are same, then you assume that one case it is a center point and you assume that another case it is not a center point. If it is a center point, you perform the pop operation. If it is not a center point, perform the no push, no pop operation. Sorry, push operation. If it is center point, means, for example, you have to do like this, two cases. If it is A, so first case, A push it. It is not a center point, and both are same. I mean to say that. Sorry, let me go with this. Initially Z naught, right? A Z naught. Both are not same, so push it. Both are same. Then you have to assume two cases. One case, you assume that this is not a center point and push it. In another case, you assume that that is a center point and you have to pop out. Like that. Same way here. Both are same. In another case, you assume that this is not a center point, push it. In another case, you have to assume that this is a center point and you have to pop out. If you do like, then if any one case reaches is the final, then we can say that that is accepted by the PDA. Right? So then how we are going to construct here? See, here I know exactly AZ push it, AB push it, same guys. So BZ push it, BA push it, same. But if both are same, you have to do two cases. Assume that this is not a center point and perform the push operation, and assume that there is a center point and perform the pop operation and change the state. Because after center point you have to perform pop. Means you write these two, right? Whatever we have written here, you write down these two as IDs. See, Q naught AA, we are going to the Q naught by performing push operation. And write down this Q naught AA, we are going to the Q1 by performing pop operation. See, same state, same input symbol, same stack symbol, but going to two different states. That's why we are calling it as NPDA. Right? See, if you know exactly what you have to perform, that is DPDA. For some reason we are having two possibilities, then that is NPDA. Everything is same, guys. Everything is same. As I don't have the C, I'm assuming that if both are same, okay, there may be a possibility of center point. So that's why I'm performing push once, I'm performing pop once. For the same reason, we are having two different possibilities. For every region, we are having only one possibility. But here, two possibilities. That's why we are saying that it is NPDA, non-deterministic push-down automata. Let me go with some differences, right? So of course we'll discuss more other languages of NPDA and DPDA in the next unit. That is, we have a classes of context-free languages, deterministic context-free languages. In that video we'll discuss what are the examples other than this WWR which are not accepted by the DPDA, that we'll discuss. Before that, let me go with the differences. So of course, as I told you, NPDA is more DPDA, right? So DPDA is less powerful than NPDA. Why? Means NPDA is accepting this, but for this you cannot construct the DPDA. No DPDA exists. So means there are few languages which are only accepted by the NPDA but not by the DPDA. That's why NPDA is more powerful than the DPDA. Automatically NPDA is more powerful than DPDA. DPDA is less powerful. Okay. So it is possible to convert every DPDA to corresponding NPDA, because every DPDA is NPDA. But every NPDA may or may not be DPDA, as I told you now. So regular languages, DPDA and NPDA, subset superset theory. Every subset type must be superset, but a superset may or may not be subset. Right? The language accepted by the DPDA is subset of language. That's what I've given. Right? So the language accepted by the NPDA is not a subset of the language accepted by the DPDA. So we have some other differences also. Okay. Right. So in next video, we'll discuss about how to perform the minimization of CFGs. Why, as I told you, to convert into the CNF or GNF. Why we need it? To convert the CFG to PDA. So to perform this, we need the minimization. So that we will discuss in the next video.